So we're going to start with transforming quadratics. Now, I don't know if you've even worked with quadratics before. Quadratics, you have? Yeah, they make it's called a parabolic shape, or a parabola they usually call it. It looks kind of like a U, can face up or face downwards, and there's many different kinds of it. We tend to have an original one here, and we're going to go into a program and see what this y equals x squared, this would be our original one, what that looks like. Now this is considered, which is important for us to remember, this is considered the vertex form, okay, of a parabola. Have you seen this before?
Yeah.
Yeah? Oh, good. And the vertex form gives us a lot of information specifically about the vertex of the parabola, which is the lowest or highest point, depending if it's facing up or down. In fact, the vertex will be kind of the x will represent the h and the y will represent the k for our vertex. Now it's a little backwards with the x. If it's a positive 5 in here, that means our x value of the vertex is negative 5. And k is intuitive. In other words, if it's positive 2, then it's positive 2, the y value of the vertex. Okay? So we're going to go through a couple of these rules and then we'll play around with it. Okay? So we'll talk about a last because it's actually many things it does. We'll talk about k. If we have a value in for k, so here's our equation and we have some number outside like plus 5 or negative 8 or something like that. If it's a positive value, what we do is we take this parabola and we move it up. And if it's a negative value, well then we move the entire parabola downwards. Okay, so what does that mean? So we'll go to our program. Y equals x to the power of 2. So here's our parabola. So let's talk about the original parabola. The original parabola has, this is our vertex.
Yep.
It's at 0 and 0. It has a point right here. Nice if you click that. 1 and 1. Okay. Has another point at negative 1 and 1. These are very important, and it's important that we actually try to memorize what this original one looks like. Do you recall this at all?
Sort of.
Okay. So if I go over to 2, do you know what the y value will be of this parabola?
2 and 4.
2 and 4, just so I happen to click it. If I go to negative 2, what will the y value be?
Negative 2 and 4.
Negative 2 and 4. It's symmetrical. Okay. So if I go to the value of 3, let's jump up, in fact, actually. There you go. If we go to the value of 3, we'll be at 3 and 9. And look, there's a ton of values in between as we go across, okay? But those points will make it a lot easier for us to draw. If I can plot those points, I can kind of draw this, okay? So remember we talked about our k value, y equals x squared. Oops, sorry, I want this squared. What value do we say? Plus 5?
Yeah.
So when I do plus 5, oops, it's equals. You'll notice the vertex of the parabola has now moved up 5 units. It's gone up 5 from where it was before. Okay. Let's say, what was another value we wanted?
Negative 5, I think it was.
Okay, let's go negative 2, just so it's a different value. We'll go to negative 2, and if you notice, the vertex has moved down 2 units, and now at 0 and 2. Okay, and we can play with that all day and figure out our different values of our vertex. Okay, so these are examples of movements of k, and I've just turned them off so we can look at our original again. Okay. Let's go back to our next rule. Our next rule here was h. And I remember we talked about how h was kind of backwards, right? If h is positive, we go left, which is technically a negative direction. And if h is negative, we move right, which means it's a positive direction. Now, it's really confusing why that happens, and really what it is because there's a negative in this equation. So when I have x minus and I plug in positive 5, I simplify by writing x minus 5, when really I put in positive 5. Okay, so let's take a look at it over here. Now, in this version, y equals, we'll have brackets around the x. Plus, and actually what I'll do is I'll go plus 0 to start. Plus 0 to start. Okay, and if you notice, nothing's happened, just like if I go plus 0 here. So if we have just the normal value, we have the normal parabola, right? And I'm going to I just want to have our original up here again. Okay, so if you take a look, and get rid of this purple, if k is 0, the vertex doesn't move, right? It's still there. And here, if h is 0, we change the color, the vertex still hasn't moved, right? It still stays the exact same. So now let's actually put in values for h. Can you see this? Yeah. Y is equal to x. What number would you like?
Doesn't matter.
Each pick one.
6.
6. Or positive or negative?
Negative.
Okay, so let's try negative 6 to the power of 2. And what has happened to our vertex from the original one?
It moved right 6.
That's right. It's moved to the right 6 units. Let's go the other direction. What kind of number could we plug in there?
Negative 5.
Okay.
Sorry, positive 5.
Okay, so positive 5, so we can go a different direction. Great. And if you notice, the vertex is now moved to the left.
Yeah.
5 units. Okay, so that's what our h value does. It moves the parabola left and right. And we can have an h and a k affect one parabola, right? So right now I'm just doing one at a time. Go back to our original. Finally, on the other page, let me just see how time is here. Oh, great. It's doing great. A is relatively confusing, okay? Now, first thing, if A is a positive value, so if we have a positive value in front, it's going to open upwards. If A is a negative value, it's going to open downwards. If A is a number greater than 1, it's going to become thinner or stretched. Think of like elastic band, right? If we have, this is the original parabola, and we pull it from the top and the bottom, it becomes thinner like an elastic band. And if A is between 0 and 1, it becomes wider. So if this is our original one, think of it like crushing elastic band. It would go like this. It would get wider and wider as we crushed it. Okay. So let's test that theory out over here. Now, A is the only one that's a little different. Y equals, I'm going to put the value of 1 in, x squared. Okay? So A is the only one that's not 0 in our original parabola. A is actually a 1. So let's play with that. Y equals, let's go with a stretch. Stretch means greater than 1. So what value would you like? 5x squared. And if you look, our parabola is much thinner than it was before, right? Makes a much thinner parabola here. Let's make it wider. Y equals, we need a value between 0 and 1.
0 and 1.
Between 0 and 1.
Negative.
Negative will actually be less than 0. Let's think of like a fraction. So maybe just say 1
Over 2.
Sure, 1 over 2, half x squared. And if you notice, we'll get rid of the green one, which is thinner, from our original, which is in red, this has become wider.
Yeah.
Okay? And the greater this fraction is, so I'll change this number, say make it 9, the wider it becomes. Okay? So we have that now. And also, we have the option of going downwards. Y equals, and actually in this case, I'm going to go negative 5 x squared. And if you notice, when I turn the positive 5 on, they're mirror images of each other. They're just as thin. The only difference is this one's facing downwards because it's a negative value. And in our other one, let's do a negative 1 over 9 x squared. Right? And let's turn back on the positive value. They're mirror images again, just so that the negative value is going down, facing downwards, and the positive one's facing upwards. Okay? Does these ideas make sense?
Yeah.
Okay, so let's try throwing everything together here. We know the original one is y is equal to the a value is 1, our h value is 0, and our k value is 0. Plus 0, and look at that, I got the exact same spot, same parabola. When I change those values, that 1, that's my a. When I change my h or my k is when this is going to become different. So let's say I wanted to make it thinner and face down. Can you give me a number for a?
1 over 3.
Okay. 1 over 3 will make it wider. So I
so
want to
make
make
it thinner. So 1 over.
We
It
need-
has to be less than 3.
it's got to be greater than 1 the value.
Oh, okay. 2.
2, sure. So it's going to be thinner, and we also, because it's going to face down, we want it to be negative. I also want this to, let's say, go to the left 10 units. Okay, so I put positive 10 for my h. And I want it to go up 6, plus 6. There we go. So if you notice, okay, this vertex from here, he has gone to the left 10 units, up 6 units, and he's become thinner and face downwards. Very different from the original one we had. Okay, so that's what all of these do with quadratics, and the best way to kind of learn is to even play with that stuff, to play with this program and get ideas of what they're going to look like.